Hello everyone, it's Mr. Brewer, and today we're going to talk about electron configuration. If you take a look at our periodic table, elements are arranged based on the number of electrons they have. You can by their atomic number up on top. The top number tells you the number of electrons. Well, we're going to tell you where they are around the nucleus. We know the electrons travel around the nucleus, where they are. We're going to tell you what level they're in and what subshell they're in. The numbers on the ones right here, for example, will tell you what level they're in, okay? Then there are subshells labeled S, P, D, and F. And if you take a look, you can see S right here. You can see there's D right here. There's P right here. And down below are your Fs. Those are the subshells that they are in. We're going to talk about how we figure out where and what levels of sublevels the electrons are in. So if we take an example of neon right here. Neon has 10 electrons. Those 10 electrons, so what we're going to do is we're going to start right over here at the very top. And we're going to go to the levels that we have. We know that our first level is the 1s level. And we have two of those. So we would write for neon 1s2. Superscript 2 up there for the 2 electrons. So let's go down to the second level. So we write 1s2, 2, and there's 2 in this one, S2. And we got to keep going all the way till we get over to neon. So if we go here to neon, the next level, going across, would put us at 2p, and if I count 1, 2, 3, 4, 5, 6. This is the electron configuration for neon, 1s2, 2s2, 2p6. Let's take a look at aluminum. Aluminum right there. Aluminum is right down on here. It's got 13 electrons. So if we were going to write it, we start over here in the upper left again, and we'd write 1s2. We'd write 2s2 as we follow across. Now we're coming over to the p's. We'd get 2p6, okay? And then we come down here to the third row, 3s2. And as we move along, we come over to aluminum. It's the first one in the 3p, so we write 3p1, all right? And if I add up all of my superscripts here, my 2 plus 2 plus 6 plus 2 plus 1, it should all add up to be 13, which is the number of electrons for aluminum. Let's go down and take a look at calcium. Calcium is right here. It's got 20. Okay, 20 electrons. So let's start from the very beginning. 1s2, 2s2, 2p6, following it, 1s2, right at the top. Start in second level. Then we go to 2p6 right here, 3s2. And then we come all the way across, we would have 3p6. And I come back to the fourth level, 4s2. And I have calcium. And if I total up my superscripts again, I got 2, I got 10, 12, 18, 20. Perfect right there for calcium. Now, sometimes this is a lot to write. And so what we do is we do it by what we call the noble gas configuration. So if we were going to take potassium right down here, number 19, okay? I'm going to write 19 right beside it. 19 right there. We don't want to write, just like we did for calcium, all the way out. What we can do is go to the neon gases. The neon gases are in group 18 over here on the far right. And we can use those to write it. So if I was going to write potassium, I'm going to write a K, because that's my potassium. And I know I'm going to go to the closest previous neon gas. That would be argon right here. So right here on the far left is my potassium. I come back. This is my last noble gas that I hit when I actually started doing this whole thing. So I could write Ar, and then I start from right there. So instead of writing 1s2, 2s2, 2p6, just like I did for calcium up here, I can go all the way over to Ar right here and put that in parentheses, and then I can write Ar4s1. Ar has 18, potassium has 1, that would give me 19, which is what I want for electrons. So Hope that helps you out. Take a look, read through what the assignment says to do. Take a look and read the instructions because it'll help you also. But this is a video to hopefully help you along. Thank you very much. Have a great day, everyone.